Hello, welcome back to Algebra. The title of this lesson is called Multiplying Polynomials Part 1. Now, in the last few lessons, we spent quite a bit of time talking about how to multiply terms in algebra. We started by talking about multiplying a monomial on the outside times multiple terms on the inside. And then in the last couple of sections, we talked about multiplying a binomial times a binomial. We've done all of that practice. So if you haven't done that yet, please go back and do those lessons first, because this lesson is just an extension of everything we've learned in the past. Once you understand the concept of multiplying binomials, then multiplying any kind of polynomials together just becomes like clockwork. It becomes something that's mechanical, because once you know the concepts, then doing the more advanced problems is really just an exercise in practicing. So to show you that, let's go down memory lane a little bit and we're going to recall what we already know really quickly so that we can extend it to what we're doing in this lesson. So for instance, if we have x squared on the outside of a parentheses, and we're going to multiply it on the inside by x cubed plus 2x, what do? See, this is just a single term on the outside multiplied by this binomial, so you just take this and distribute it in just like you always have. So when we take the x squared times the x cubed, we multiply them and we can add the exponents. We learned all of that in the rules of exponents early on. So what you're going to have is x to the 5th power. And then we take that term and we multiply it by the other term in the parentheses. So the 2 times the 1 gives you 2, and then the x squared times the x gives you 2x to the cubed power. The reason that it's a plus is because you have a positive term times a positive term gives you a positive term. If you don't understand that, then you need to go back and review the last several lessons where we've done that kind of work, okay? Now the next most common thing that we're going to run into, or the next most complex thing I should say, is what we learned in the last section. And that is that we can take something more complicated on the outsides, for instance, x squared plus 1 on the outside, and multiply it by a binomial. So we have x cubed, again, let's just make it easy, plus 2x. So you see here we've had the same exact binomial, now we're multiplying it times something a little more complicated on the outside. But as you should know by now, all you do is pretend that the 1 is not there. You take this and distribute it in. And so what you're going to get is what we just got before. You'll have x to the 5th plus 2x to the 3rd. That's this times this, and then this times this. Then you pretend this is not here. You multiply the 1 in times here. You get another x to the 3rd power. And you take this and multiply it times this, and that gives you 2x. So you have 4 terms. And now you see you have these terms that can be combined together. So for the final answer, you'll have x to the 5th power plus, since these are the same exact variables and exponents, you can add them together. 2 plus 1 is 3, and you'll have x to the 3rd power, and then this comes along for the ride because we can't do anything else with it. We cannot add these terms together because they have different exponents of x. This is a different term than this one, which is a different than this one. So you have x to the 5th plus 3x to the 3rd plus 2x. Now, what we talked about in the last section was the concept of FOIL, and that's what we just did. I just didn't call it FOIL. But what you have here is this first term is the F term, the first terms, and then the outside terms are these two giving you this one. The inside terms are these two giving you this one, and the last term are these two giving you this one. So think of it as FOIL, or what I like to say is think of it as covering this up, distribute this in, and then cover this up, distribute this in. Basically, everything on the outside has to go in and multiply by everything on the inside. And the reason why I'm explaining to you that way is because in this lesson, we're going to be multiplying more complex things than this. Let's say, for example, let's get to the material of today's lesson. A little more complicated than what we've done. By extension, what if I have the same thing on the outside here? Let's call it x squared plus 1 on the outside. But on the inside, I change this and make it a little more complicated. X to the 3rd power plus 2x plus, let's say, plus 4. Now, if you didn't learn it this way, then you might be very confused about how to handle that, because most students, when you're taught this, you learn binomial times binomial, you learn FOIL, first, outside, inner, last, first, outside, inner, last. You just learn to do it, right? But the problem is if you just memorize FOIL, then you have no idea how to handle this, because you don't know which are the first terms, which are the last terms. I mean, you might guess these are the last terms, but which ones are the inside and the outer, because it doesn't match this cookie cutter thing. So that's why this whole time I've been telling you, visualize it as x squared times these two terms separately, and then cover this and visualize it as these two terms. Why did I do that? Because now that we have a more complex problem, you don't memorize FOIL. What you do is you cover up the 1, and you pretend all you have is this. So these two terms multiplied together is x to the 5th power. And then again, the 1 is not there. Then you distribute this one into this one. 2x times the x squared gives you 2x to the 3rd power. We just add these exponents. Then you take this one and you go into the last one, and you'll have 4 times the 1 gives you 4, and then x squared is right there. So you've completely distributed this outside term times everything. Now you cover him up, pretend he's not there. This term now needs to go in and distribute itself to everything inside. So 1 times x cubed is going to be x cubed. 1 times 2x is going to just give you 2x. And 1 times 4 is just going to give you 4. So you see how in the case of the binomials, because of the number of terms, you had 4 terms in the answer. Because of this one, you have 2 times 3, 6 terms in the answer. But notice that a lot of them are similar, right? Because you have 2x cubed, and then you have x cubed right here, so that you can actually simplify these. So we're just going to look for same terms, see if we come across anything. X to the 5th, we don't have any other x to the 5th terms, so this becomes the final term in the answer. Then we have this term matches this one, so we can add these together. 2 plus 1 is 3. 3 what? 3x cubes. We have the 4x squared. We don't have any other x squared terms, so we have 4x squared. And then we have the 2x. We don't have any other x terms by itself. And then we have the constant 4. We don't have any other numbers. So the final answer is x to the 5th plus 3x to the 3rd plus 4x squared plus 2x plus 4. And this is the final answer, so you can circle this guy. If you really do understand what I've just done, and I've tried to break it down as simple and as step-by-step as I can, but if you understand this, then there will be no problem I can give you that will be actually hard. All of the problems that follow are going to basically be doing the same thing over and over again for practice. The only thing is sometimes you have minus signs. See, I had every term in here was positive, so I didn't have any negatives to give me a chance to make an error. Or whatever. But the point is that there's going to be more chances to make errors as I make the problems longer, but the process never changes. So let's go to the next example just to kind of get a little more practice. What if we had the example 2 times c plus 1, and I'm multiplying that binomial times c squared minus 3 times c plus 2. All right, so again, I pretend the 1 is not there, and I distribute this into each term separately. So the first terms, and I do encourage you on your paper, put your fingers on there to help you keep track of it. 2c times c squared is going to give you what? You're going to have 2c cubed, because you're just going to add the exponents of the c variable. Then this one gets multiplied in, but it's times -3 now. -3 times 2 is -6. So the -6 is here, and the c times the c is c squared. Then you take this one and go times the 2. 2 times 2 is 4, positive 4, times c, because don't forget I have a c right here, and there's no c here, so it has to come along for the ride. Now I've kind of run out of space here, so I'm just going to continue on the next line. But now I'm going to pretend the 2c is not there at all. 1 times c will be positive, or I should say 1 times c squared will be c squared. 1 times the -3c is -3c. 1 times 2 is 2. So I have all of this stuff plus this stuff. And then all I have to do is simplify terms. So 2c cubed, I don't have any other c cubes, so that stays in the answer. C squared, here's the only other c squared I have, so -6 plus a positive 1. What's -6 plus positive 1 is -5. 5 what? 5c squares. So this term, and this term are already taken care of. Now the 4 plus the -3, or you can think of it as 4 minus 3, is just going to be 1. And 1 what? 1c. You don't have to put the 1 in front there. And then I have a constant of 2. There are no other constants in my answer. So I get 2c cubed minus 5c squared plus c plus 2. This is the final answer. So every other problem that we're going to do in this lesson is going to be very similar, but we're just going to have slightly more complex scenarios here. For instance, what if we have t minus 3? 2t squared minus t plus 2. Now the only thing that makes this tricky is I have a minus sign here and a minus sign there. So as I do my distribution, I do need to be careful when I multiply negatives and positives to get the right signs. So what I'm going to do, instead of doing it this way, I'm going to write my equal sign underneath so I can fit everything on one line. So what do I have? T times the first term, which is 2t squared, will give you 2. 2 times 1 is 2. And then you get the t's and you add those exponents together, giving you t cubed. Then this one times this one, this is negative. So -1 times the positive gives you negative t squared. I add these exponents together. T times the 2 here is going to give you 2 times t, right? Now I've done that. I've distributed that into every term. Now I cover this up and pretend I have only the second one outside, but that negative sign is still there. So when I distribute this in, it's -3 times each of these guys. So what's this one going to be? -3 times +2 gives me -6. T squared times nothing there is just going to give you the t squared. Right? Then -3 times -1 gives me +3. And then the t goes with, there's nothing else there, so the t is just coming along for the ride. Then -3 times +2 gives me -6. That's the constant term. So then I start looking for similar terms or like terms. So this one, there are no other t cubes anywhere, so I say 2t to the 3rd power. So that takes care of this term. Then I have t squared. This is the only other t squared here. What's -1 plus a -6? Or you can think of it as -1 minus 6. That's going to give you -7 t squareds. Then I have this term and this term. These are similar. 2 plus 3 is 5 t, right? And then the only thing left in the answer is -6. This is the final answer. Let's double check. 2t cubed minus 7t squared plus 5t minus 6. And that's correct. So I hope you're starting to get some familiarity for how we're doing this. I cannot stress how important it is to master the skill, though, because every topic that we do from here on out will have these polynomial multiplications in them. So you do need to get good at it, and that's where we're doing a lot of problems. Now let's turn it around a little bit. In all of these problems, I had 2 terms out here, here's 2 terms, multiplied by this trinomial, which is 3 terms. So binomial times trinomial. Now take a look at how this one differs. What if I have x squared plus 3x minus 5, and then I'm multiplying that times x plus 2. Now see, if you're just memorizing things like FOIL, F-O-I-L, not only do you not know how to do the last type of problem, but you don't know how to do this one because what's in front is actually 3 terms multiplied by 2 terms. So it differs even more than in the past. But now you know, you're not going to fall for that. All you have to do to multiply this is every one of these terms has to individually go in and multiply times everything over here. So what you do is you cover both of these up, pretend they're not there. This has to be multiplied in by those terms. Then you cover both of these. This one has to then be multiplied by both terms. Then you cover both of these. This one has to go in and multiply by both terms. So what you have is, what is x squared times x? You're going to get x to the 3rd, add the exponents. X squared times 2 is going to give you 2x squared. Then you move to the next term. This one has to go in to both of them. So 3x times x is 3x squared. And then 3x times 2 is 3 times 2 is 6, so you're going to have 6x right there. Now this one's a minus 5, -5. So -5 times x is -5x. And then -5 times 2 is -10. So you see, we still have the same number of terms. 1, 2, 3, 4, 5, 6. Why? Because we have 3 terms on the outside, 2 terms on the inside. 3 times 2 is 6. We get 6 terms. Just like here, we have 2 times 3 is 6. So you see, the order, you have to be careful. You have to just make sure and distribute everything in, but we still expect to get 6 terms because of the total number of terms we have over here. So then we say, how many x cubes do we have? We have none, so this is just going to remain x cubed. How many x squares do we have? Well, I have one right next door, so 2 plus 3 is 5, x squared. And then these are like terms. What is 6 minus 5? It's going to give you 1, so just write it as x because it's really 1x. And then you have minus 10. And this is the final answer. Let's double check. X cubed plus 5x squared plus x minus 10. So that's the final answer. All right. Let's take a look at one that's about the same complexity. We're just getting some practice. A little bit higher exponents. It's the only real difference. What about y to the 4th power minus 3y squared plus 1 multiplied times y squared minus 2. The only real difference between this and this is I have a higher values of exponents, but exactly the same thing is done solution-wise. So we start with the first term and we start multiplying it in times both of these. What are these two multiplied together? We add the exponents together because the base is the same. So that becomes y to the 6th power. 4 plus 2 is 6. Then we take and multiply times the negative 2. Don't forget this is negative, so you get negative 2y to the 4th power when we multiply these. Then we move here and we do the same thing again. To the first term, negative 3 times 1 is negative 3y. We add the exponents, 4th power. Then negative 3 times negative 2, don't forget your signs, makes it a positive 6, and then you have the y squared from here. Now we're done with this term, so we shift our finger here. 1 times y is y squared. And then 1 times negative 2 is negative 2. And we should have 6 terms, and I think you can convince yourself that you do have 6 terms. So y to the 6th, we don't have any other terms like that, so he's going to stay in the front. Now we have y to the 4th. What's negative 2 minus 3 gives you negative 5. Y to the 4th power. These terms are the same. 6 plus 1 is 7. Y squared. And then the minus 2 comes along the right. So let's go ahead and circle that and check it. Y to the 6th power minus 5y to the 4th plus 7y squared minus 2. All correct. Now only one more problem in this lesson. Notice that what we've done is we've started with the simplest thing. Distribute on the outside. Got that. Okay, what happens if we have 2 things on the outside? We distribute both of them then. Okay, what if you have something bigger? We just distribute each thing in, as we've always done. What if you have 3 things on the outside? Well, you just distribute each term in from the outside to the inside. Now for our final problem of this lesson, you should see the pattern by now. What do you do if you have this? What if you have x squared minus x plus 2 multiplied by x squared plus x minus 1. So this is 3 terms times 3 terms. So this one's larger than any of the other problems before, but by now you should see the pattern. We just take this first thing and distribute it in, boom, boom, boom. That's 3 terms right there. Then we move here, distribute it in, boom, boom, boom. That's 3 more terms. Then we move this one in, boom, boom, boom. That's 3 more terms. So 3 times 3, we should expect to see 9 terms altogether. Let's just double check and see what we get. So we have x squared times x squared gives you x, add the exponents to the 4th power. This times this gives you x to the 3rd. This times this, negative 1 here times that gives you negative 1x squared. So negative x squared is what you write down. Then you shift your finger to this. This is a negative x times this. Negative 1 times the positive 1 means you get a negative x. You add the exponents and make it to the 3rd power. Then this one times this one. This is negative times positive gives you negative x, and you add the exponents, which means x squared. Then, whoops, we have one more, times the negative 1. Negative times negative is positive x. X times 1 is x, right? Then we shift here. We have 2 times the x squared, so we get 2x squared. Then we have 2 times the x. Then we have 2 times the negative 1, which makes negative 2 for the final answer. 1, 2, 3, 4, 5, 6, 7, 8, 9 terms, that's what we got. Now we simplify. There are no other x to the 4th, so he stays in the front. We have an x to the 3rd term. Now here's where things get interesting. We have an x to the 3rd term here. You have an x to the 3rd term here as well, but it's a negative. So this positive 1 cancels with the negative 1 in front of the x to the 3rd. So here what we actually get is 0 when we add these together, right? Because 1 plus a negative 1 gives you 0. So the x to the 3rd terms drop away completely. So we say, okay, we'll remember that, but let's go and take a look at the x squareds. Well, here's a negative x squared, and here is another negative x squared, and here's another positive 2x squareds here. So we're going to basically add all these. So let's go and say, well, we're going to add these, and we're going to add it to this one down here because that's an x squared term, that's an x squared term, and that's an x squared term. But here's what you have. Negative 1 plus negative 1 gives you negative 2x squared. That negative 2x squared is going to add with the positive 2x squared, and these terms are also going to give you 0. I'm putting a slash through it so you don't think I'm writing an O or something. Basically, these add to 0, and the x squared terms add to 0. So you've actually canceled a lot of your answer because this term is not going to be in the answer. That term's not going to be in the answer. That term's not going to be in the answer. That one's not going to be in the answer. This one I have done nothing for. So for now, just because I've done so much, let me write it down. And then this one is going to be in the answer. Let's just keep it for now. We'll add it later, and then we have the minus 2. Basically, all of these terms that touched red are gone. Then in our final answer, we just add these. 1 plus 2 is 3, x minus 2. This is the final answer. X to the 4th plus 3x minus 2. So, congratulations. You now know how to multiply polynomials, right? We start off by teaching you the basic idea about how to distribute terms in. and then you learn binomial times binomial, then you learn trinomial times trinomial, and now I hope you can see that you can now multiply anything times anything, no matter how many terms I give you. The same pattern holds. You just distribute everything on the outside times everything on the inside, and as everything gets larger, you're going to have more and more terms to simplify at the end. So we've done this, and you should have a good foundation for how to handle these things. But follow me on to the next lesson. We'll continue multiplying polynomials, crank up the problem complexity just a little bit, but you will be able to understand how to do all of them because all of them follow the exact rules that we've laid out in this section.